Simplify this equation. What we have here, we have a whole bunch of radicals. First thing I always like to do is convert them into fractions. Again, just to recap, if we have the bth root of x to the a stays with the base, becomes the numerator, and the power of the radical becomes the denominator of the fraction. So in this case, let's write all of these in terms of fractional exponents. We have 6 here, which becomes the numerator. 4 is the power of the root, so that becomes the denominator. Here we have x squared, and that's under the fourth root. So we have x to the 2 over 4. We're going to multiply this times x to the 12 over 4. So hopefully you follow along with that. Now when we have division and the same basis, what we do is we subtract the exponents. So we have x to the 6 4 minus 2 fourths, and we multiply that times x to the 12 over 4. So we have x to the 4 over 4, and we multiply that times x to the 12 over 4. Now when we multiply and we have the same bases, we add the exponents. So we have x to the 4 over 4 plus 12 over 4, and that's equal to x to the 16 over 4, which is equal to x to the 4th power. Notice how I didn't simplify everything as I went along. I just kept them in terms of in fractional form. Like here I didn't convert that to 3, here I didn't convert that to 1. It really doesn't matter. In this case, if you had done so, it might have turned out a little easier. On a lot of different questions, however, you typically want to keep it as a fraction because you don't want to waste time recreating a lowest common denominator or finding the least common multiple. So that's just another time-saving strategy or tip as well. In this case, make sure you review your exponent rules, know how to convert from radicals to exponent, fractional exponent forms. Also, you know what to do when you multiply two numbers with different exponents where they have the same base, or when they have different exponents the same base and you divide.